In today's video, we're going to talk about a very important concept in data structure. It's the hash code. Used in many algorithm problems, especially in the code interviews. Very important concept. I have wrote a beginner-friendly blog on Medium, so we will use this as a PowerPoint to talk about what it is. Imagine we have a magic mailbox. Inside the mailbox, we have a lot of letters. You need to find one letter out. But because this mailbox has piled up with so many letters, it takes forever to read one by one. So in this scenario, how can you fetch this letter quickly? So here is why the hash code matters. Instead of looking letters one by one, we will encode each letter inside this mailbox into a number, like into a hash code. This information is much more shorter than the whole letter. And when you need a specific letter, you just need to go find this corresponding hash code. That's how you get your letter back. Here is this Python examples. It just turned a string using these hash functions. It turned into a hash code like this. This is how it really works in the Python programming scenario. We can use these hash functions. But this hash function comes with Python itself. It uses some sort of algorithms to get this hash code. But actually, hash function, it's just a concept. You can write your own hash functions. It convert a thing you want to convert into something much more simpler. And that's what hash function does. We need to talk about these hash tables. In Python, the hash tables, you can think about it as a dictionary. It has key value pairs. So the key, the hash value itself. The value part is the thing actually you are stored. For example, the previous scenario, this letter will be stored in the value part and whatever the hash code will be stored at the key part. Here, I also attached a real world scenario used in many big companies. This LeetCode questions 49, the group anagrams. How to apply the hash code into this scenario. We have an array of strings. We need to group these anagrams together. So an anagram it's a word or a phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. For example, this eat, it comes with letter E-A-T. This, if we put it into alphabet orders, it will be A-E-T. That's always A-E-T for this letter, right? And same for the T. If you break all these letters apart, it will always be A, E, and T. But this 10 cannot break into the pattern of A, E, T, the letter A, letter E, letter T, because it has an extra letter N here. We need to group these anagrams into one groups, and we need to show this whole groups how it looks like. Here, you can see in this group, the group 3, it has all the letters A, E, T, but they put into different orders, form different word. This is a very typical scenario to use hash code because if you just look at all these letters, it's just random stuff. But if we somehow convert this word into a hash code, we put them to the correct hash boxes. Previous place like this in this dictionary, we just put this stuff into the correct place. We will have a key for all these groups, and this is the content itself, and another key for this one, and another key for this one. Here, this key, what I'm talking about is the hash code itself using as a key. We have many approaches to do this. If we look at the code about this question, we can define a hash table using a Python dictionary here. And what inside this hash table is we just convert all these words into hash code. And once we convert that and we put them into the right boxes, right? Let's get the hash code key first. So when you have whatever string, for example, you have this EAT string here, how do you convert it into a hash code? Here I wrote a function called get hash code key values. We can calculate, for example, in this word eat, how many times E have appeared, and how many times A have appeared, and how many times T have appeared. This EAT, they only appeared once. So we have 26 letters, and same for this one, and same for this one. We will group all these into same box. So here we define a box for letters. So we have 26 arrays, which the original value is 0. And then for these boxes, you can think about it like we have 26 spot for this very long pattern. For letter A appeared right now, it's 0 times. But for this eat word, it will be for the letter A, it appeared once. Somewhere in this later for the letter E box, it appeared once. And then later for this T box, it also appeared once. This very long list can be used as a hash code, hash table keys, because this pattern only works for eat, for T, for 8. It doesn't work for T10 because there is no N inside of this. The N part will be 0. But for eat, for T, for 8, they would appear the exact same order as this long list. So we take this whole long list as the hash code key. So here we use another thing called a tuple to put this long list inside. A tuple is just a list that cannot be changed. Python can use this tuple as a key in the dictionary. So now we have this hash code as a key. Just need to iterate this string atoms inside all the strings. We will check inside the hash table, does this key exist before? At the beginning, of course, it doesn't exist. We will just get this empty array and then append it and then put this array into its value. And if we find this key, for example, for this AET patterns, we find this, we will just append it. So in this way, we just put all the strings into correct hash code key boxes. And in the end, what we need to do is we just need to print all the values of this hash table. So we will just use a list to take out all the hash table's values. And then here we go, we get a output just like this. And here I want to talk about some common mistakes people will make in this scenario. For example, some beginners, they would use ASCII code for this EAT and to sum it up as a key. This is not feasible in some scenario because, for example, this letter A, ASCII code is 1 and B is 2 and C is 3 and D is 4. Let's say AD and then BC. If you sums up at AD or sums up BC, it will all equals to 5. 5 cannot be the hash code for these two. It doesn't differentiate these two. 5 will be AD, 5 will also be BC. Also, some people might use the order, like put this EAT, for example, let's use this as example. Use the alphabet order as a key. We will use this as a key for this hash table. Well, this works, but it's a little bit slow compared to this algorithms when it just counting how many times each letter appeared. Because when you sort this AET, it also takes time. Imagine this is a very long strings. Sorting this thing compared to count the frequency for this, of course, just counting the frequency will be quicker, right? Because you just need to iterate it once. Complexity is O(n), and for sorting, most like average scenario, the complexity will be O(n) log n, right? So that's why. So here we go. This is quick tutorials. Thank you guys.